Hello guys, in this video we are going to discuss the solution of the problem summed matrix. So let us look at the problem statement. The problem statement says that a matrix is constructed of size n by n and given an integer q. The value at every cell of the matrix is given as mi, j is equals to I plus j, where mi, j is the value of the cell, I is the row number and j is the column number. Return the number of cells having value q. So for instance, in this example, the dimension of the matrix is given to us, which is 4 by 4, and q equals to 7. So as you can see, the matrix as given in the question is constructed, and this is the matrix we will get. Of this, the number of cells containing 7 is 2. This is one entry, and this is the second entry, because of which we are returning 2 in this case. Similarly, in the next example, the dimension of matrix is 5 by 5 and q equals to 4, and as you can see there are 3 entries for 4, because of which we are returning 3 over here. So that's about the problem statement, folks. Now let us discuss the solution of this problem. So in order to discuss the solution of the problem, let us take an example. Let us say n is equals to 5 and q is equals to 3. So with n equals to 5, this is the matrix which we have. Now if you look at the matrix carefully, you will realize that there is a pattern over here, and the pattern is, if you see this diagonal has only 6's in them. In this diagonal it is all 5's. This diagonal has only 4's. Similarly, this has 3 and this has 2. And if you look at the lower half of the diagonal, that also has the same number, right? This diagonal has 7, this diagonal has 8, and this diagonal has 9, and this diagonal has 10. So in a sense, what we can see over here is that every diagonal has a repetitive unique entry. So what do I mean by this? Well, what I meant by this is, if you see this diagonal has a unique entry which is 6, and all the cells of this diagonal has the same entry which is 6. Similarly, if you look at this diagonal, it has a unique entry which is 9, and all the cells which are comprising of this diagonal has the same entry which is 9. So this is one observation which we can draw by observing this matrix. Now let us see how we will be able to use this observation in order to solve this problem. Now as we know that matrix I, j has the value I plus j. So what is the maximum value of the matrix? Well, the maximum value of matrix I, j will be when I is equals to n and j is equals to n. So which will be equals to 2n. Now we know that the maximum value the matrix can have is 2n. So our first condition is pretty straightforward, which is if q is greater than 2 times n, then q does not exist in the matrix, because of which we can return 0. The number of cells containing q will be 0 since q is greater than 2 times n. Now let us look for the cases where q is within the range of 2n, where q is less than or equals to 2n. So in order to find out the number of cells containing q, what we need to find out is this diagonal. And what do I mean by this? I need to find out the unique entry which will be there in the longest diagonal. So let us see how we will be able to find it out. Well, the value over here, so this value can be written as 1 plus n, right? Because this is at entry 1 comma n, and that is how this is 1 plus n. So we know that the value over here at this position, the value will be 1 plus n. So the longest diagonal value, let us call it longest diagonal value, will be equals to 1 plus n. Now with reference to this longest diagonal value, we will be able to find the number of cells containing q. Now if q is equals to 1 plus n, then that simply means that the value q lies in this diagonal. And since in the matrix this is the longest diagonal, so the number of elements this diagonal will have is n, right? The number of elements or the number of cells the longest diagonal will have is n. So because of which, for this case, what we can do is we can simply return n. For the cases where q is not equals to 1 plus n, for such cases, what we are going to do is we are going to compute the absolute difference between longest diagonal value and q, and this absolute difference between the longest diagonal value and q will give me the diagonal in which q lies. So for instance, if you see in this example, here q is equals to 3. So for this case, our longest diagonal value will be equals to n plus 1, which is equals to 6. So 6 minus 3 is what we are computing, and this is our difference. And since I'm taking the absolute difference, so 6 minus 3, which is equals to 3. And how can we use this diff in order to find the number of cells containing q? Well, the way we will be able to use it is, so the number of cells containing 6 is equals to n. Since this is the longest diagonal, and the size of the longest diagonal will be n. Because of this, the number of cells containing 6 will be equals to n. Similarly, if you go down, the number of cells containing 5 will be equals to n minus 1. The number of cells containing 4 will be equals to n minus 2. Similarly, the number of cells containing 3 will be equals to n minus 3. So this is the relationship between the longest diagonal and the value of q. And let us use this now in order to code this. So once we have diff with us, all we have to do is return n minus diff. And this is how we will be able to find out the number of cells containing value q. So that's the whole explanation, folks. Now let us see how we have implemented in C++ and Python. So first, let us implement this in Python. So the first thing which we are going to do is we are going to check whether q is greater than 2 into n. If q is greater than 2 into n, then there isn't any cells containing q, because of which we can return 0. Otherwise, we need to compute the longest diagonal sum, and the longest diagonal sum will be given by 1 plus n. So the longest diagonal which we have, the value of the longest diagonal will be 1 plus n. Once we have this, now let us compute our difference, and the difference will be equals to absolute sum longest diag sum minus q. And once we have this, now we need to find out the number of cells containing q, and that will be given by n minus difference. And that's the code, folks. Now let us do a quick try run. So there isn't any issue with this code. Now let us submit our solution. So our Python solution got accepted. Now let us look at the C++ implementation. The C++ implementation is the same, where if q is greater than 2 times n, then we are returning 0. Otherwise, we are finding out the longest diagonal sum. And once we have the longest diagonal sum, then we are computing difference, and then the number of cells containing q will be given by n minus diff. Now let us submit this solution. So our C++ solution got accepted. That is all from this video, folks. In case if you have any question or comment regarding this video, please feel free to use the comment section and I'll try to address them. Thank you.